Hello everyone. So today in this episode of planet generation system, we are going to look into how to implement clustering for foliage types in this foliage spawner. So as you can see here, we don't have like just randomly placed tree instances. We have some kind of clustering system going on here. So here, this is the function that we are going to work on today. Here I have created parameters to give number of steps and seeds per step. So this would be similar to this clustering parameters that we see under procedural foliage clustering settings. So I'm going to connect to them later on, but for now we are going to implement this function. So here, for example, if I make this spread distance 1000 and number of steps only 1 and respawn foliages, now you can see there are not much of clustering happening. And in the cases where we have two trees, they are close together. But if I now increase this, let's say 3000, and number of steps, if I make it 4, compile and spawn foliage, now you see we have some more foliages like this, and they are spreading like in a clustered behavior. So yeah, this is what we are going to work on today, how to spawn foliage clusters in this planet. And I can actually walk on this planet as well. Let me fly around, it's faster, but I can walk too. And since we have already implemented the planet gravity system, we can walk no matter where, even if even we land on this other side of the planet, the character aligns properly. So yeah, and we have a spawned foliage system on the planet. So yeah, this is what we are going to work on today. So in case you don't know, that I have released multiple videos in this planet generator system previously, and I have provided the link to this full playlist which contains all the episodes of the planet generator. Link is in the description below in case you want to refer to that. Before we get started, I'd like to remind you can download the project files of this project and all other thousands of projects that I have done in my channel. To the date, there are over 1800 videos, and for each video you can access project files. Once you become a member in the Patreon page without a limit, you can download anything without a limit. Feel free to check it out. I'll leave the link in description below. And back to tutorial. Okay, so in this system, now that we do have a system to spawn foliage, but at the moment it's just only one instance randomly across the landscape. So the next step I want to do is having some clustering system. So rather than having just one foliage instance, maybe when we have only one in the places where I have one tree, I might have like a cluster of trees. So for that, first let me open my planet blueprint, and here for testing I'm using only one foliage type, which is this one. This is a static mesh foliage asset, and here I already have a way to define clustering parameters, but it's not visible at the moment because they come as a part of experimental procedural foliage system. So here under editor preferences, experimental, here if I enable procedural foliage, and if I open this asset again, now you see there is a new section called procedural, and under that I have clustering. So here we have number of steps and initial seed density, average spread variance, so many things are there, but these settings are not exposed to blueprints as for the moment. So we can try that here. See, number of steps or anything, they don't appear because they're not exposed to blueprints. So we might need to use either some kind of a C++ adapter class or a helper class or something to expose those variables, but I'm not going to do that for now. So the only thing what I want to do for now is, instead of adding an instance, I'm going to add a cluster. So how should we do this? Okay, here I'll convert this to a function. I'll keep only this ISM foliage as a input, and I'll select everything else and then collapse to function. I'll call it add foliage cluster. So I'll name this one ISM foliage, instead static mesh component foliage. Okay, now here I'll add some parameters. Scale, scale variance should be a float, and then clustering. Well, I need the number of steps, so number of steps, and then spread distance, and then spread variance. So spread distance and variance is fine. Number of steps should be an integer. I'm actually defining these variables that I have here under clustering. Number of steps and initial seed density, I don't think I need to integrate into this function that I'm working at the moment. So we need the spread variance and spread distance, and also seeds per step. Here, seeds per step. Okay, and I'll move this next to number of steps. Okay, now for now, since I don't have a way to get these values directly from that asset itself, for now I'll hard code them. So scale variance, I'll give it as 0.2. that would mean 1 to 1.2. Oh, I'll make it 0.5, and the number of steps, I'll make it 3 seeds per step. Let's keep 1. Spread distance maybe 2000. Spread variance 1000. Okay, now here I'll connect this scale variance like this, so that I will have something in between 1 and 1 plus this scale variance. So if I put 0.5, it would be in between 1 and 1.5. right now, and well, rather than doing that, think it would be better if I just give a direct value for min and max. Yeah, let me remove scale variance and get like this scale min and scale max. This way it's more practical and easy. One 1.5. Okay, cool. Now the next step is simulating this number of steps. So let me break this and scale in so that we can keep the code clean. Scale max. Right, now let me put this aside for now, and we can have a for loop starting from 0 and runs up to this number of steps. Okay, I think I will have to start from 1, otherwise we will always have number of steps plus one additional step. So okay, and the next step is, so here we get an index. This index gives us which step is this. Alright, and the position I get from here, but rather than getting it like that, I think I should get it as input. Oh wait, no, I actually set this calc helper calc root location. So yeah, we can keep using this. Okay, so now how do I integrate this seeds per step? That would mean another loop starting from 1 and ends at seeds per step. Okay, right, now here if I multiply this index with spread distance, alright, why can't I take this spread here, get spread distance and spread distance of variance. So multiply this by spread distance and then add a random value based on this variance. So random float in range between 0 and 1. Right, now this will give the deviation, the distance of deviation that we need to have from the starting position to in this step in the cluster. So this is not 100% accurate, but this would give some kind of a clustering behavior, and that's enough for me. And we need to apply this. Here I have the calc root, and I have set the calc root as the location of the point that we are going to spawn the cluster. So the next step is here I'll get this calc child and set relative position, relative location of it using how? Okay, I'll just connect this to X and Y. So, but this could be in either direction, positive or negative. So select float with the random pool. Random true would be 1, false would be -1. Right, this should give us some kind of a clustering behavior. Right, oh, not yet, not done yet. We can now get the character child and get the world location and rotation. Oh wait, we also need to consider that this point might be above ground because there can be slopes in the ground. So what we can do is we can get this location and we'll have to do a line trace by channel to determine the flow location. So how to do that? Like this. I don't think we can use the exact start point like this, but we can get at the location which is the center of the planet, and then direction vector, unit direction vector from the center of planet to this. Well, we can consider this way also. So in that case, starting point would be this multiplied by, let's say, 2000 units, and then so if I add if I add the result of this to this point, that would give us a point below the surface. So that should be our endpoint. So here, but if I subtract, that should give us a point above ground. So like this, and at that should be the end. I'm not sure if I need this. This might freeze the engine because we might be placing a lot of foliage. So let's try without the debug visualizer and see if it works. So only if we get a hit, we should plant a tree. Right. Okay. Let's enable the debug lines for 10 seconds and test. Okay, we see the debug lines, but I don't see the trees. So it registers as no hit for some reason. Yeah, I don't see the hits. Why? I think I have enabled this trace complex. Otherwise, it may not detect the ground. Still no. Sorry, I have enabled this ignore self. That should not be ignored because we are testing the planet. So right, see, now it works, but the ground, it's way above. Alright, that's fine, because now instead of using this location, what we should do is break the hit result and use the location of the hit. Right, now this should work. Let me make it for 1 frame and spawn foliage. Yeah, now we got trees with some kind of a clustering behavior, but I see them as like they are clustered along a line for some reason. Why is that happening? Okay, because I have connected the same output, so I might try something like this. Can I collapse this to a macro? I'll call it instance offset, and then I'll have 2 of them and use that for Y. Compile and spawn. Now I think we have broken that line. Yeah, great. Now they are no longer spawned in a single line. Okay, so good, clustering is working. So now if I want, I can change the parameters here. Let's say 2 seeds per step. Oh, one more thing, if I make this 2 seeds per step, then here this should go not just until the seeds per step, index multiplied by seeds per step. That's the way it should be, because if I have 2 seeds in the first step, in the next step we need to have 4 seeds, because those 2 also gives the initial 2 trees should give another set of seeds. Yeah, and also you see they are stacked on one another, which is something we should avoid. But how? Here we can check the other component that being hit. I don't think I need to drag a long line from over there, so let me make it shorter by doing it like this. That's not relevant for what I was talking about. So I want to place only on the landscape, the trees. So what I can do is we can check the hit component and check if it is equal to the dynamic mesh component. If yes, we can place a tree. So that should avoid placing trees on top of each other. Yeah, that did it. Okay, so I think that's good enough. Let me play. and take a look at the forest I spawned. Right, nice. It's simple, I know that, but we have free functioning planet with trees now, even though it's simple. So we can build upon this. So next time I want to look into how to have multiple foliage types, and also we need to have low level small scale details, things like grass as well. So yeah, let's look into those things in future episodes, and I'm gonna stop this episode right here. So thanks for watching. As always, updated project files will be available for the download in Patreon page. Link would be in the description below. And see you in another episode. Goodbye. I actually forgot one more thing. Here I randomized this rotation of the 𝐂𝐚𝐭𝐫𝐨𝐧 so that I have random yaw rotation compared to the normal of the tree in each instance. So I should have done that before this step, like this. Okay, now we should have better results. All the instances should have a random rotation. Yeah, see, looks better now. Okay, all right, that's one small detail. So yeah, thanks again for watching. Don't forget to like and subscribe. See you in the next episode. Goodbye.